I'll just right click, add an emitter, I'll take the fountain, and next force in this tutorial I will cover is after curl noise the drag. Very simple, it has already a drag here because on the fountain. So I can delete this and I can add this again from the forces. I can take this drag. So basically drag does what it means. So and I'll show you. So let's say you don't have gravity in particle. Without drag, particle just going up on the same speed. So if you increase the drag like this much, see, particles spawning and they have some speed, but eventually they stopped because drag is there. You can also use a curve if you want drag at the very end. So you can use like initially it is 0 and at the end it is like 50. So see, particle have speed here, but they are stopping there. So very cool if you have like uh, this kind of point velocity, particle will stop on a surface of a sphere like this. Very cool. So then we have a rotational drag. So what it does basically, if I take like this material, so it is square. Now you can see the rotation. And let's say you have velocity like linear velocity and 100, and I'll make the drag 0. Particle going up, right? And I'll decrease the spawn rate like 10. So particle going up, and let's increase a little bit more. And there is a random rotation. I can turn this off so particle go straight. You can see. Also, I can turn the sphere off and make the size like 10, 10. So now it is very straight, particle going straight. So you can add a rotational velocity here. I have a separate tutorial on the rotational velocity in my velocities category. So this is the rotational velocity. You can, but it will work on a mesh because it has this 3 vector, not 2. So basically, I'll delete this and I'll take a mesh, and by default we have this mesh. I'll just turn this off. So these are all going straight. Cool. And now if I add a velocity, they are rotating. Let's take different mesh. It's not very clear. I want you to like, I'll take the box. Actually cute. And I'll make the non-uniform size. So we have this, right? Now with the velocity, these are rotating on this angle or maybe this angle. They are rotating. Now there is the drag, rotational drag. So if I increase this, it will not rotate. And if you like add a curve and you use it like this, so if I increase this like 10, they have rotation initially, but they are stopping there. Cool. So that is very useful when you use debris. They are rotating and colliding on the ground, and after colliding, they should stop with a drag. Cool. So let me show you a different method doing the same thing. So let's say instead of the rotation, I'll have this velocity con, and I'll also use the gravity. So particle rotating, and also take a collision, and I'll take the analytical plane. So it will collide here. I'll make my location little up. Let it compile. The particles are now colliding. Let me increase the life, maybe 5. They are colliding with the ground, but still they are rotating. See? So now if you use this drag, what will happen? Let it compile. They are rotating initially, but after the collision, they are stopping. Although the axis is not the perfect, but you can fix that. I have different tutorials on it. But now you have this cool example how this works. So drag is very simple, but I made a long video on it. So I hope now it's clear. Thanks. Bye.